Good morning, ladies and gentlemen. Go ahead and do this now. What is the charge on 45 electrons? And then how many electrons are required to make negative 2 coulombs of charge? What is the charge on 1 electron?
Well, 1 Coulomb, that 1 Coulomb is equal to 1 Coulomb.
Negative 1.6 times 10 to the negative 19th, right?
Yes, it is.
These little 1 electrons. See, even we have to look at our notes sometimes. It's okay. And so we can make a fraction out of this, right? And it's negative here because electrons are negative, right?
Yeah.
Okay, what is the charge on 45 electrons? So we're given 45 electrons. Let's go ahead and do our stuff. So again, don't forget, this is just multiply across and dividing by the bottom here. And if we've got electrons here, we need electrons there. And what are we trying to find? What is the charge? The charges are
There's going to be coulombs.
coulombs, okay? So attached to electrons that's a 1. Yikes, okay? And up here, we're going to write attached to coulombs is negative 1.6 times 10 to the negative 19th. Okay. From here, it's easy. We just multiply across, and we don't have to divide by 1 because that's ridiculous. 1.6 times 10 to the negative 19th, and I get negative 7.2 times 10 to the negative 18th. Okay. 7.2 times 10 to the negative 18th. These cancel, and I'm left with coulombs.
And I think that should be a negative 7.
Oh, you're right. Sorry. Negative. That's what I said.
There you go.
Negative
You
because
said it.
negative.
Yeah, I heard you say it.
And that makes sense because electrons have a negative charge. Your answer should be negative.
That's right.
And if I asked for a proton, it would have been
Positive.
positive, right? Okay, so number 2, how many electrons are required to make negative 2 coulombs of charge? Okay, so I know negative 2 coulombs of charge. I'm going to start with that. Okay, and whatever units I have here, I'm going to put them on the bottom. Whatever you're given goes on the bottom there. And then we're trying to find electrons, the number of electrons. How many electrons? Okay, so attached to coulombs is this number, negative 1.6 times 10 to the 19th, negative 19th coulombs. And then over here, we've got 1. All right, we plug it in. All right, negative 2 divided by negative 1.6 times 10 to the negative 19th, and I get 1.25 times 10 to the 19th. That's a positive, right? That makes sense because 10 to the 19th. It's asking how many electrons. We can't have a negative number or something, right?
Yeah, and you've got a negative divided by a negative, so that makes a positive.
Yeah, so we're multiplying across, dividing by the bottom. Okay, my chemistry kids always have kind of trouble understanding that for the first couple times.
And so that's going to be that many electrons.
And this is a big number.
Yes, it is.
Okay, all right. What's next? Let's grade your lab. Okay, so we're talking about the electroscope lab right here. This little guy. And Mr. Boykin went and bought us some cute little balloons. Okay, check this out, you guys. So here's our balloon. Okay, boop. Doesn't that stay on way better than this guy? Like, look at this. He's like, barely even staying on anymore. I can't even be bothered. Get out of here. I'm gonna put him on.
The small balloons weigh less.
Yeah, I'm gonna put him in the trash.
There you go.
He's trash. I'm gonna go ahead and walk through this and demonstrate it with you guys, and we're gonna grade it. And what I want you to do is, as I go through, just make each slide 1 point. So each question is 1 point. So question 1 has 2 parts, right? A and B. So you make.
Well, let's take a look at them and see what it says.
I can't remember. Okay, so here we go. And go easy on yourself. You know, it doesn't have to be perfect here. All right, so step 1. What happened? So we rub the balloon across the knob like this.
The leaves spread apart.
And the leaves spread apart.
So that's 2 items you should have written down. You rub the balloon across the knob, the leaves spread apart.
Okay, if you don't have it written down, write it down, and you give yourself 1 point for that. Okay. Step 1, why? Sorry, why did this happen? Electrons were transferred to the knob from the balloon.
Yep.
And then electrons traveled down the leaves and negative charges in the leaves repelled each other.
So all of this is metal. It's all a conductor. And she put the electrons on the top. They went down to the leaves spread apart because the electrons repel each other.
And there is positive charges down there, but there's more negative charges.
Yeah.
Okay. Step 2, what happened? So this is when the finger touched the knob and the leaves collapse.
Yeah.
Like that. Okay, one point for that. Step 2, why did this happen? Okay, so what's going on here? So when I touch here, the leaves collapse. What is going on? The electrons are escaping into my finger.
Yep.
Right, and then eventually go to the ground. The leaves are now neutral, so they stop repelling each other.
Gravity just causes them to hang down.
Yeah.
Okay, the next one is where you brought the balloon close, but you didn't touch it.
Yeah, so this is when, okay, I bring it close. Okay, and what is going on here? Okay, so we brought the balloons close, the leaves spread. I moved the balloons away, the leaves collapsed. So why did this happen? Electrons in the balloon repelled electrons in the knob, right? So this is really negatively charged, and in here pretend there's 4 positives and 4 negatives.
Yeah.
And as I come closer,
Run away,
the electrons, yeah, those electrons in the knob, they're running away down to the bottom of the leaves. And the electrons ran down the leaves, causing repulsion, because now there's more negative down in the leaves, and so it's a more negative, okay?
Yeah.
Without the balloon, okay, I pull the balloon away, so balloon here, they run away, down to the bottom, and I pull it away. There's no more negative charge there. The electrons come back up and everyone's happy.
All those electrons that are down in the leaves repel away each other, and so they go back and redistribute themselves as far apart as possible.
What is this called again?
Induction.
Induction. We're inducing a charge. Okay,
Step 4, the hard one.
Okay, step 4, what happened? So let me see if I can remember what happened. So we bring the balloon close, they repel. I touch this right here.
They collapse.
They collapse.
Take your finger away.
Take my finger away.
Take the balloon away, and now they spread back apart. So you brought the balloon close, the leaves spread, touch the knob, they collapse, remove the balloon, the leaves spread apart. Why?
Why? What is going on? So the balloon repels electrons. So as I bring the balloon close, it induces a charge, right?
Right.
Okay. And then when I put my finger on, okay, now the electrons that were running away and repelling the leaves apart, I put my finger on, and the electrons all run out.
Well, not all of them, but
not all of them.
So the electrons on this side go down. They also go to the other side of the knob. When she touches it, the electrons have a place to get away.
To escape. Okay.
And then she takes her finger away, and now the electrons that are missing are stuck, and so you have missing electrons in the electroscope. That makes it. So
basically, we have the same number of electrons at the beginning. I bring the balloon here, they run away.
Yep.
Right, and then I put my finger on, and they're like, and some of them escape out my finger.
Yeah.
When I take my finger away, we're not getting those electrons back.
That's right.
Right. So you just have lots of positive protons in there because they can't go anywhere, and now missing electrons equals a positive electroscope.
So add up the number of points you got.
Yeah. And I think what I'll do is I will just I'll make this a text question. Oh, I should have done that for the pairs quiz. Now that I'm thinking about it, and you could just put your number, whatever score that you gave yourself on there. Okay. So there's 4 questions, 2 parts to every question. We'll call it 8 points. Okay. All right. Coulomb's law. Coulomb's law. Super cool. Coulomb. Okay. So our electrical force equals our constant right here, which we have a value for, charge 1 times charge 2 over d squared. This looks complicated, but
it's the same. You've already done it with gravity.
Yeah.
It's basically the same thing. It's just your calculator knows how to do it.
Yeah, and you just said earlier, Mr. Boykin, it's like a times b times c over d squared.
That's right.
Right? So, you know, the complicated part is not really that complicated. It's just, you know,
the scientific notation.
Yeah, being able to put those numbers in the calculator. Okay, so here is the value for our electrical constant K, 9 times 10 to the 9th. Let's take a look at these units. So we've solved this equation for our constant here.
Yeah.
And so our units for our constant are newtons, which is here, meters squared over Coulomb squared.
Yep.
Makes sense.
And let me talk about this relationship right here. Why is it constant? Well, if you make them farther apart, this number gets bigger, the force gets smaller. So this number gets bigger, this number gets smaller. They balance each other out, and the constant remains the same. If you have more charge, you get more force. So the bottom gets bigger, the top gets bigger, it stays the same. It's a constant relationship.
That makes sense. Where's that? Okay. Practice. Okay, so what is the electrical force between these two charges?
Whoa, that's 1,000 meters apart. That's a kilometer.
Ooh, wait.
If you've got, that's a long way, right?
It sure is. Okay, guys, go ahead and get started. Miss Moore's gonna figure out where she put her marker.
Right here
There
in the
it
book.
is. Okay, so let's see. It wants to know the electrical force. The electrical force. Oh, make it a biggie. Okay, electrical force is equal to the constant times Q1 times Q2 over the distance squared. Okay.
And so you've got the two charges, one's negative, one's positive.
Newtons meters squared over Coulomb squared times, one's negative, one's positive. We got negative 1 Coulomb times 2 coulombs all over.
And they are a kilometer apart, and you square that.
Now, do we use kilometer or meter for this?
I beg your pardon. They're 1,000 meters.
1,000 meters, right? Okay. Just making sure.
No.
Let's just plug it in here. Okay. Let's see what we get. So when I plug this into my calculator, I'm just going to plug everything in the top end. No parentheses, extra parentheses are needed. And then I'm just going to divide it by the bottom. So 9 times 10. And I can use my E button, as you guys
You better
see
use
me
your E button.
doing. Negative 1 times 2. And I just divide that all by 1,000 squared. And I get negative 18,000.
18,000 newtons. That's a huge amount of force. So this is an indication of the size of a Coulomb of charge. It's a tremendous amount of charge. So even though they're a kilometer apart, that's 18,000 newtons.
I mean, that's like to my house,
Yeah.
at least.
So now let me ask you, why is that? That answer is negative? Why?
So the answer is negative because we're talking about the force from one thing on another, right?
Yeah, but what in the calculation? Why is it negative?
Oh, there's a negative because there's a negative 1 right here.
And everything else is positive.
Yeah. Oh, hey. There we go.
There you go. So
Yeah,
a
so-
negative times a positive gives you a negative.
Yeah, let's point this out. So a negative times a positive number here gives me a negative number here, right?
Yeah. So what kind of force is this? Electrical force.
So when we have when we have opposites here, we have attraction, right?
That's right.
Okay. So
What kind of force? It's either attraction or repulsion, and opposites attract.
Okay, attractive force, attraction force. What do you say? The force of attraction.
Force of attraction, an attractive force.
Attractive. So attractive force or force of attraction.
We're getting all grammatical up in here.
And you know what? When we ask you, what kind of force is this? It's okay to do this. I mean, I say negative plus a positive gives me a negative, okay? And I look here, I say positive plus a negative. These are opposites.
Yeah.
Okay, and opposites
Attract. That's good.
Okay, and on to the next one. Okay. So now we're even further apart.
And we have less charge.
Okay, so let's see what's happening here. So my electrical force is going to be, I'm just going to go ahead and plug in the numbers here. So
Yeah.
I've got 9 times 10 to the 9th newtons meters squared over Coulomb squared times negative 0.5
Negative 0.5 coulombs.
times negative 0.2.
Negative 0.2 coulombs.
Okay, all over 2,500 meters squared.
Yep.
All right, so here we go. 9 times 10 to the 9th. Okay, times a negative 0.5 times a negative 0.2 divided by 2,500, and I square that, I get 144.
144 newtons. And that's 2.5 kilometers apart.
Newtons, okay. All right, and let's take a look at these signs again here, right? Okay, so here we have a negative, okay, right here, times another negative, and negative times negative gives me a
positive.
Okay, there's a positive number right here.
So what kind of force are we talking about
Okay,
here?
we know that same repel, so we're talking about repulsion.
Yep.
Okay.
All right.
Repulsion. Got it.
You think you guys can do this if we cut you loose on somebody?
Before we, we just went over this. What does it mean if the electrical force is positive or negative? Well, if it's positive, we're talking about repulsion. If it's negative, we're talking about attractive forces.
Yep.
Okay. And then, we have this question. What is the force of attraction between the proton and the electron in a hydrogen atom if the distance is this much?
Well, we're going to use Coulomb's law, but what piece of information do we need that it's not given us?
What is the charge on a proton and an electron?
Okay.
Well, the electron is going to be negative 1.6 times 10 to the negative 19th coulombs, and a proton is going to be a positive negative, like this, right?
Yep, so go ahead. See what you can do with this. Pause the video. See if you can do this, and then we'll talk about it.
Okay, it's going to be a test of whether or not you can type stuff into your calculator. Times positive 1.6 19 coulombs all over 7.9 times 10. They're really close to each other.
Well, it's an atom. That's
Yeah.
that's not hecka small. That's hella small.
Hecka. Okay. All right.
Let the scientific notation begin.
All right, here we go. So let's see. Can you see how my screen okay here, Bookend?
Not really.
Okay,
But go ahead.
Okay, so I'm just gonna no parentheses. I'm just gonna plug and chug in here. So 9e to the 9th times negative 1.6 e negative 19 times 1.6 e to the negative 19 divided by, I forgot to square that on the bottom, you guys, 7.9 e to the negative 11th, and I'm going to square that. Okay, and I get, let's see, what is the force? Negative 3.7 times 10 to the negative 8th. Okay, hold on. Square right here. Okay, negative 3.7 times 10 to the negative 8th newtons.
Now that's a very small amount, but we're talking about an atom, and we're talking about an electron and a proton, and the force of attraction. What keeps that electron buzzing around the proton?
Mm-hmm.
It's that force of attraction.
Mm-hmm. Right there. And why is it attraction? Negative, positive, opposites attract.
That's right. Simple, yes?
Okay, yes.
So what's the hard stuff about this?
Okay.
Putting it in your calculator.
I know. Okay, so solve this for Q2. Should we lift up the screen and do this with them?
Yeah.
Look at these guys, they're on a ride of their life. Come on. Look at them up there, you see that? Okay.
What do you want to start with?
All right, we're trying to find Q2 right here, right?
Yeah.
So let's get rid of the bottom part first.
Okay,
and put it
that's
over here.
division. How do you undo division?
We're gonna undo division with multiplication. So D2 times distance, not D2, distance
D squared.
These cancel out.
Yeah.
Okay.
And now you got multiplication. How do you undo multiplication?
We divide.
Yeah.
So I'm gonna divide by both of them at once.
Yeah.
Okay, I can get rid of K and Q1 in one fell swoop. Okay, so I'm gonna divide by K and Q1. Okay, K cancels, Q cancels, and now we're left with Q2.
2 is equal to D squared times FE
over
KQ1.
boom.
Boom to boom to boom.
Okay, so
Now, why do they need this? It's because
well, we're gonna give you guys a homework question. Bada boom, right There. So you're going to do on page 476, oh, right here. How lovely. You're going to do problems 1 and number 2 and up here, okay? And these ones, right?
Yes, 1 and 2.
And number 2 wants to know the magnitude of the force on the second charge. So for number 2, you're going to use that question down there, that equation down there, okay?
Now, let me just show you something here. If I rub this on my arm and put it right there, where are the electrons that I rubbed off my shirt onto here?
They gotta be.
They're on the back.
Right in the back, right?
And if you look around, oh, look at it. Oh. So regardless, the attraction is where the electrons are on the balloon. What does that mean? It means the electrons are staying right there. And why is that? It's because
static electricity.
Means it's stationary, not moving, and that's an insulator that doesn't let them move. All right, have fun with the equations.
Woohoo!